Hello everyone. This movie should be the last movie for our chapter 5. We have learned or we have watched some movies already for covering chapter 5. So now it comes to the last movie for chapter 5. So we still have one concept in order to study for chapter 5. This is principles of counting. Principle of counting is the last point for our chapter 5. To facilitate counting, we have three counting formulas. So three counting formula can be used in order to facilitate counting. So they are: 1. Multiplication formula. Okay, so you must not confuse multiplication formula with multiplication rule that we already learned from previous movies. Okay, so in this case, multiplication formula. Second one, permutation formula. Permutation formula is the second formula. The third one, the combination formula. So we have three counting formulas can be used in order to facilitate the counting. Okay, first looking at multiplication formula. In order to study multiplication formula, in order to use multiplication formula for principal counting, at least we have two things or two problems or two events or two objects. Okay, in this case, for example, we have one thing and the other thing. If there are m ways of doing one thing and there are n ways of doing the other thing, so we will have m multiplied by n ways of doing both things. Okay, so we have one thing. In order to do this thing, we have m ways, and we have the other thing. In order to do this thing, we have n ways. So in order to do both things together, we have m multiplied by n ways. So the total number of arrangement is m multiplied by n if we have two objects or two problems or two things with different numbers or way of doing those things. Okay, in case we have three things differently, so we also have three ways of doing three things. For example, in this case, there are three ways m, n, and o are doing three things, so we can get the total number of arrangement for doing these three things together is m multiplied by n and multiplied by o. Okay, this is a multiplication formula. So we do multiply. This is multiply. If we have two objects or two things, so we must have two numbers of ways. If you have three objects or two things, in order to do these three objects or in order to do this three things, we have three numbers of way, and then we multiply them together. Okay, look at the example. For example, Dr. Key has 10 shirts and 8 ties. Okay, Dr. Key has 10 shirts and 8 ties. So how many shirt and tie outfits does he have? How many ties and shirt that he can put on his body? That means how many ways, how many styles of shirt and tie together put on his body. So there are 80 styles or 80 arrangements of shirt and tie together. Okay, so you can practice example on cell review 5.10 on this page. 5.10 on this page. This one. Okay, this is example, and this is a cell review. Okay, so I just show you this one, and you can study by your own time. and try to practice it in order to get more clear understanding. Next is about permutation formula. Permutation formula. In order to study permutation formula, you need to have number object, and you select sum among all number object that you have in order to make arrangement. But this arrangement we consider the rank or the order. That's why the order or arrangement is important. So in order to study permutation formula, you need to have some objects or something, and then you need to select sum among object that you have. Okay, you need to select some item or some among what you have. But in what you select, you need to think about order or rank. What does it mean, order or rank? That means from maybe older to younger, or older to newer, or maybe from tall to short, or maybe from cheaper to more expensive, something like this. Okay, maybe from, yeah, it depends on problem that you study. But remember that in order to study permutation formula, you need to think about order of our arrangement. So any arrangement of all objects selected from n possible objects. So any arrangement of all objects selected from n possible object. So in this case, remind you, or must smaller or equal to n, or cannot be bigger than n. Okay, bigger not accepted. Or because among n you select all number. Okay, you can select all. If all equal to n, you can select all, but all less than n, you can select less number, or less number compare with n. But in this case, when you use permutation formula, be careful. You need to think about order. Like I said, order maybe from younger to older, from poorer to richer, from short to tall, from older to newer, or maybe, yeah, it depends on what you study. But in this case, permutation order is important. Okay, order is important also. Okay, this is a formula that we use in order to study permutation. But some textbook, they may use this one. Okay, they may use this one, maybe or among n or something like this. I'm not specified that one because it depends on the textbook. But this textbook saying permutation all among n. Permutation all among n is equal to n factorial. Okay, if you read in French, factorial, but in English, factorial is equal to n factorial divided by n minus all factorial. Okay, what does it mean, n factorial? N factorial is 1 from 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by blah 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 up to multiplied by n. This is n factorial. Okay, so in order to study permutation formula, you need to select objects among all objects that you have. That's why, as I mentioned earlier, all here, what you select, amount that you select among total n that you have, or must be smaller or equal to n. But in this case, for permutation, when you select, you must think about order. So the formula that we use in order to study permutation is here. Permutation all among n object equal to n factorial divided by n minus all factorial. Okay, for example, what is p? P is a number of permutation. is the number of permutations or ways that objects can be arranged. N is total number of objects that you have, or is the number of objects that to be used at one time, to be selected at one time. So note, this is note. N mark here stand for n factorial, that equal to 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by n up to n. 0 factorial equal to 1. So far some student asking me why 0 factorial equal to 1. I will show you this one. Okay, so we know that 1 factorial equal to 1 multiplied by 1. 2 factorial equal to 2 multiplied by 1. 3 factorial 3 multiplied by 1 multiplied by 2 multiplied by 3. 4 factorial 4 multiplied by 3 multiplied by 2 multiplied by 1, up to n factorial n multiplied by n minus 1 multiplied by n minus 2 up to divided by 3 4. Okay, yes. So n factorial equal to n multiplied by n factorial, n minus 1 factorial. So this n is different from n minus 1 factorial. Now if we suppose n equal to 1, in this case, if we suppose n equal to 1, that's why n factorial 1 factorial equal to n 1 n equal to 1 and minus 1. That's why 1 factorial equal to 1 multiplied by 0 factorial. So because 1 factorial equal to 1, that's why 0 factorial is equal to 1 in this case. Okay, so this is the way why they show why 0 factorial equal to 1. Okay, for example, in one team there are 13 members. In one team there are 13 members. The team leaders must pick up 5 members among 13 to comprise. Okay, to comprise a starting line up with the height of each member. So select 5 members among 13 in order to ask them to stand in a line. Okay, when they stand in a line, they must think about the height. So normally the short stand first, and the taller, and the tallest it should be stand the last of the line, the last position of the line. So how many different lines up are possible? How many different lines that we can do it? Okay, so we find possible numbers of different lines. So we have n 13 or 5. So because of this example, we focus on height of each other's line up or stand in a line. We consider about height of each member. That means the shorter should be stand first, taller stand next, and taller stand next, taller stand next, and the tallest should be stand at the end of the line. That's why this is the thing about range. So we use a permutation. Okay. So 13 n factorial divided by n minus or n 13 minus or 5. That's why 13 factorial divided by 8 factorial. So 8 factorial or 13 factorial, I can take 13 multiplied by 12 multiplied by 11 multiplied by 10 multiplied by 9 and multiplied by 8 factorial. Why not I get multiplied from 8 to 7 to 6 up to 1? Because down here, up below the bar, division here below the bar, I get 8 factorial. That's why I can cancel it. Okay, I can cancel it. So you don't need to extend it up to multiply by 1. Why we need to take a waste time to do nothing? That's why we do just this. Then we multiply by from 13 up to 8 factorial, and then we can cancel it. So okay, I got some problem for students. When they cancel, some students they say that this is 0. Okay, 8 factorial here, 8 factorial down here, they cancel. They say we still have nothing, now 0. No, it's not 0, it's 1. Okay, it's not 0, it's 1. So why is it 0? Cannot be 0, it's still 1. Because it's 8 factorial, I can say that 8 factorial multiplied by 1. 8 factorial multiplied by 1 is still 8 factorial. Okay, that's why not 0, it's 1. So what the rest I can take 9 multiplied by 10 multiplied by 11 multiplied by 12 multiplied by 13. This is number of arrangement with a height order. Okay, with different orders, team leader can pick up 5 members among 13 members to arrange 154,440 lines up with students with members height. Okay, so this is a very short. Remember that permutation, when you pick up when you select some among object that you have to put in a line or to make arrangement, you need to, if it is think about order, we use permutation. If we select some object among all object that you have and to take it as a line but without arrangement, without order, so we will use combination. Any combination of all objects selecting from n possible objects, order or combination, order or arrangement, order or selection is not important. So order is not important. When order is not important, so we will use combination. Okay, so remember that I put here in order to make you see clearly and try to recognize. So when we're talking about permutation, order is important. Order of selection, order of arrangement, order of selection is important. But when we're talking about combination, order is not important. So when order is not important, so the number of arrangement or number of combination must be smaller than permutation. Okay, so this is a formula that we use in order to study combination formula. So combination all object among n object equal to n factorial divided by n minus all factorial and multiplied by all factorial. So C stands for number of combination or ways. Number of combination or number of ways that object can be combined. N is the total number of objects, the total number of objects, and O is the number of objects that we selected for study or that is used for one time. Okay, this is maybe I'm not explain because the same thing as before. Okay, for example, again, we have one team has 13 members. Team leader pick up 5 members among 13 to comprise a lineup. But in this lineup, nothing special. No, why is nothing special? Because we don't have an order. We don't have a rank in our lineup. So in this case, how many different lines up are possible? So because our selection is not subject to order or rank, that's why you can use combination. Okay, so combination. So again, so we have this one. Now we have 13 factorial divided by 13 minus 5 factorial multiplied by 5 factorial. So we do the same thing as before, but now we have this one. We cannot find 5 factorial all up here. That's why we can extend all in order to be cancelled. Okay, to be cancelled some number over bar and under the bar. So first we can cancel 8 factorial, and next what we can cancel. Okay, before we go into this one, maybe what we can cancel more. Okay, let's say 2 multiplied by 5, 10, right? 10 to cancel it. And 3 multiplied by 4, 12, right? 12 cancel it. That's why finally we got 9 multiplied by 11 and multiplied by 13 divided by 1. Okay, so the result is, so to do this, it make you easy to make calculation. Yes, that's why this one, it's only 1000 something. Okay, so the same example, but selection the same, I mean the same example, the way that we select also the same, but one thing about order, the other one not think about order. So the number of arrangement, the number of combination, or the number of selection, it should be differently. Okay, this is the less than. So if we don't talk about the order, so we just group it, we can classify it without thinking in any special criteria. That's why we have less number. Okay, we have less number in this case. Okay, with no orders, team leader can pick up 5 members from certain member to combine 1287 lineups. Okay, so now come to the last of chapter 5. Before finish chapter 5, just go into cell review 5.11 on this page and exercise on page 175. Yes, this one. Yes, a little bit longer. Okay, cell review 5.11, this is longer. Okay, you can study by your own. And exercise for homework. Exercise on page 176. In case you want to do more. In case you want to do more. But this is not exercise. This is not homework. In case you want to do more, or you want to get more understanding, you can go to exercise number page 178 and on, and next page. But this is for your homework on page 176. This one. 40. Okay, maybe no 42. 40, 44, 46. Only 3 more. No 42. But if you want to do 42, okay, it's your optional. But homework for this point is only 40, 44, and 46. And as I mentioned in the slide, if you want to do more practice, not homework, on this page and on, this is not homework, but homework only exercise 40, 44, and 48 on this page. This is extra exercise that you want to understand more, you can do it. Okay, this is come to the end of chapter 5. Okay, turn to you to watch and study and practice, and doing practice again in order to get more understanding, in order to remember the formulas. Okay, this is for your time.